404. Hi, Gross.
Are you okay? What are you dreaming of?
I'm just dreaming of my glory days. Oh, it's bright in here. Let me tell you a story, son. Let me tell you the story of the greatest adventure ever. The story of streamline hydraulics. Our journey begins on State Highway 125. Located approximately 10 miles north of Granby, Colorado, our culvert, nestled amongst the pines, resides. This culvert is home to the Denver Creek stream. This culvert was built back in the early 50s using a 5-foot diameter corrugated steel pipe. This pipe was very adequate for many years in conveying the flow needed for this creek. And for a while there was good times and peace for this little culvert. That was until the fire came. One of the largest fires in Colorado state history ripped through the land, stripping the beautiful scenery of its vegetation and making the surface impermeable, causing high sediment flows and debris to wreak havoc on the culvert and the surrounding areas. You can see here vast amounts of sediment deposited, leaving the culvert in dire condition. Only 5 inches of clearance was left, and they needed a savior to fix this culvert. But then there was hope. CDOT arose from the ashes and sought a group to be able to hydraulically model the region using HECRAS, provide an analysis of various different culvert alternatives, develop plan drawings in AutoCAD, and finally develop a solution for the Denver Creek culvert so that it can hopefully one day meet the hydraulic demand of this area and never allow for overtopping of the State Highway 125 anymore, thus bringing about the Fellowship of the Culvert.
Let me introduce the Fellowship of the Culvert. Hans, Jack, Cale, Logan, and Trevor.
The team set out on our journey. The first step, research and development. We hit the books to find out as much as possible about our task, grinding through CDOT's Drainage and Design Manual, S&M standards, as well as the U.S. Forest Service Bear Catalog, any resource the team could find to find a solution to this task. And this, we found 3 solutions. The first alternative being a corrugated steel open bottom arch, followed by a precast concrete box culvert with a smooth concrete bottom. And lastly, a precast concrete box culvert embedded with a sediment-filled bottom. To be able to adequately test these different alternatives, we needed to call in our expert modeling team to deal with our HECRAS and HY8 modeling. Shown in the figure are the existing post-fire conditions modeled using HECRAS. As shown in this figure, you can see there is a good amount of overtopping over the road and significant depth along the roadway, which is the main cause for our address of this issue. Shown are the 3 alternatives that we were analyzing. As shown through all 3, you can see that the flow is conveyed very well. However, there's high velocities at the downstream end of our culvert, which is definitely an issue that the team is planning to address in upslope and downslope treatment with potentially using in-channel tree felling and or riprap basins on the upstream and downstream sections of our culvert. For our decision matrix, we decided to focus on 5 main components of culvert design: hydraulic performance, debris management, cost, structural strength and durability, and then maintenance accessibility. Once the group was in agreement, we made our decision. The group had decided on a precast concrete box culvert that was embedded with a sediment-filled bottom. Our cost estimate came out to $2.7 million using CDOT's cost estimate tool, as well as our hourly cost estimate of $4,000. So it came out to $2.74 million. And that, my friends, is a story of the Fellowship of the Culvert,